Kara, tell me what we're going to do today.
We're going to make a light box.
And who's that for?
Tony.
Who's she?
My mother-in-law. Your wife.
Oh, her. Oh yes, very good. No worries, cool. So what do you got there?
I've got a roll of LEDs which we've taken off the roll.
Yeah.
And we've plugged into a power source to make them all pretty.
Right, and what sort of power supply are you using there?
12 volts.
Okay.
DC.
Alright, so from what you've learnt about LEDs, what must they have in there?
Resistors?
Good, well done. Why do they need resistors?
Because they can only take a certain amount of voltage.
And typically what sort of voltage would you be looking at about?
About 3 volts?
Yeah, about 3 volts. So they've, if you have a close look in the line, you can see there's little resistors that have been put in there on the LED stripping. And the beauty about the stripping is that for a certain amount you can actually cut them. They've got scissor marks where you can cut them. So you can cut through that section, solder on wire, and do whatever length you want. And of course different areas also have solder joints which make them easier. The whole thing's encased in sort of a silicon, so it's waterproof, which is great. And so we'll start making a light box. So what we're going to do for starters is just come up with sort of a template or a mock-up of what we plan to do and see how that works. Tell us about the mock-up that we're making here, Kara.
This is for the light box. It's made out of cardboard and duct tape.
Right, why are we doing that?
Thank you. Thank you.
Editing! Right.
Okay. We're trying to do a light box.
Yes.
And it's made out of cardboard and duct tape. And the reason we're doing this is to see how bright it is underneath the glass.
Okay.
And how much lights we need to use.
Alright, so what are we going to use for lighting?
The
right,
LEDs.
Yep, so we'll just chuck them in there for now. Before we tested them, we had them laid out evenly and they look pretty good, but just for now, just to give you an idea, we'll try that. So you can clearly see that it's got quite a good light source there when the connections are good. But obviously we can improve it. There's a few things that we'll do to improve that. How are we going to find out if the light behind the light box is suitable for tracing?
Well, we've got a piece of paper with beautiful pictures on it. There's one done in pen, one in pencil, and one in texto, so
okay.
We can see the differences. And then we can put another piece of paper on top.
Right. Not sure how that shows up on camera, but how's that look to you?
It looks pretty good. We can see all of them fairly clearly.
Yep, okay. So that's our... is there any way that we can improve what we're doing there?
Yes. Well, the lights aren't really all facing up. They're sort of in all different directions.
Yeah, okay.
And also it's quite dark on the inside, so there's no reflection.
Right, so we'll paint it white, or the timber that we use will be white. Is there anything else? What about the depth of the box?
Oh, the depth, the height.
Yeah, the height of the box is quite tall, so if we make it a lot shorter, it'll be closer to the light source, won't it? Now it's time to head outside and turn this little thing into something more permanent. So what I'm trying to do is cut a rebate for the glass to fit in. What glass you say? Hang on a sec. This glass here. This was taken from a scanner at a recycling depot. So I pulled apart the scanner, threw away the rest, kept the piece of glass, said to my wife, would you like this for something? She said, yes, can you make me a light box? The glass is for the light box. So that's what the rebate's all about. Back to the rebate.
This is actually the second time he's done it.
Editing, I keep telling you. So first things first, before you play with anything, make sure you've got the power point in front of you so you can see it. I'll double check my work, make sure I'm happy that I've got it set up correctly. Yeah, close enough. It's only for the wife. Nice and tight, clamp down, it's not moving. Can now plug him back in. Nice rebate, nice and flush, just the way we want it. So for the back of our lighting box we're going to use core flute, which is like a plastic cardboard, pretty cool stuff, very cheap, and the advantage of that is because we'll get the reflective nature of the white backing, and it's shiny as well, nice and shiny. And that'll help with the lighting too, to reflect all the lights. So Kara's going to use a staple gun just to try and hold it in place. After rummaging through my power supply box, I came across a power supply that I thought would be a good idea. Let's have a look at the details, the specs. It's a 12 volt output, so 240 volt input, 12 volt output, 500 milliamps. Looks reasonably bright, doesn't it? But notice what's happening to the voltage when we put a load on it. See? It's down to 9.51 volts. Nah, no good. So I decided to rummage a little further. I came across this mega beast. Notice the specs on this one in comparison to the other one. It says 12 volt output, which is what we're after, but notice the amperage, 1.25. Let's check it out and see if that makes the difference that we're after. Whoa, seriously bright. And notice the voltage. Let's have a look at the voltage there. What's it say? 11.16 volts, much better, a lot closer to the 12 volts that we need to run the system correctly. So we're on a winner here. Kara's now cleaned up our little connector, our little socket. You can see that all the wire's gone and the holes are nice and clear. What we need to do now is connect this bit to this bit. Problem being is it's covered with plastic. So one of the tools that you can use is wire strippers. This is a particularly good brand that I use. And notice the little holes down here, they actually correspond to the thickness of the wire. So when we cut through, if we put this particular one in here, those that don't need glasses, so you can see it's sticking through, but it'll cut the plastic, but not the metal itself. So we'll do both of those, and Kara can do the other side, and then we'll solder them together. You might also notice that it's staggered, so I've got one that's longer than the other. Any idea why? Well, I'll tell you. The reason being is when I join them together, I will know which is positive, which is negative, and also I won't need to put a join here and one over the top. All I'll have to do is put one piece of heat shrink. It's our heat shrink there. We'll just put that, slide it over the top, and neither of these will contact one another. So it won't be a big bulky mass of wires, but simply a nice clean connection. Now we're going to join the wires together, and as you can see why I've staggered them, because it's quite easy to get it right now. So what I'll do is I'll do this one first, and then I'll get Kara to do the second one. So with this method, you go roughly halfway down the wire, and you bend them opposite directions like that. You twist it that way, hold one wire, twist it the other way. And as you can see, there's little daggy bits hanging on the end, so you just stretch it out a fraction. Hopefully it won't come off. and then give it a little twist, and then it should be, oops, in camera, and then believe it or not, it's actually quite tight even before we solder it. So now what we'll do is we'll solder it and make it nice and strong. Keep in mind that we've got our heat shrink on there already. I don't know how many times it's been easy to forget. You go to solder something and you go, oh, I forgot my heat shrink, but that one's on there today, so that's good. So I'll put it in our little holding device here, and then we'll solder it in place. Just make sure that the other wire is out of the road so it doesn't get melted. Okay, so the soldering technique that we need to use is we actually heat up the wire, not the solder. So you put the, and you try and stop shaking of course, because that's not really good on camera. So what you do is you heat up the wire itself. Once the wire is heated, you add just a tiny bit of solder to the iron itself, and you'll see it leach, or it sort of runs. You can see it's heating up there. You don't want any big lumps or anything like that. And you can see that's absorbing into the wire quite well. So if we have a look at that, we'll be able to see that it's a nice join. There's no daggy bits hanging out, and also there's no solder spikes or anything that's going to catch on anything, so that's good. That's a good join. So we get Kara to do the next one. Now we need to determine which is the positive pin and the negative pin, so that we can connect it up to our LEDs correctly. Keep in mind that LEDs only work one way, so if we hook them up backwards they just won't work. So we need to make sure that when we solder our wire onto our socket, we've got it the correct way. So we'll just get Kara to hook it up now, and we'll turn on the power and find out which is positive and which is negative. So the power's on there, and notice what we've got on the multimeter. It's got negative 12, hasn't it? So that means it's the other way around, doesn't it? So obviously the positive pin is in the center. There we go, positive 12.27. So we know that the pin in the center is the positive pin. Okay, so now we've done our joins and it's time to put the heat shrink on. So I'll just get Kara making sure she doesn't burn her arm on the soldering iron there, to gently heat it up, and we'll see the heat shrink go into action. You can see it shrinking down. What we're just about to do now is cut all the strips. Kara has just done it on the back of the box. You just flip it over so you can see that she's sectioned it. Yes, you can. Good. So she's sectioned it up into 9 areas, so we'll have the bars going this way, and now we need to cut them so that they will suit the box. And what we've been able to do, I haven't actually used this stuff before, so it's a bit new to me, but we've been able to cut through the scissor marks there that you can see, and just peel off the silicone, and I'm just about to solder it and make sure that that's okay. We've now cut some of the strips up, as you can see, and as I mentioned before, we've got a positive on one side, negative on the other side. We're just going to join them in rows. We've done one already. As you can see, it turned out quite well. We've got our positive that goes around to the positive, our negative that goes around to the negative. And believe it or not, strange as it may seem, but it actually works. The theory is that it works, I said. Positive and negative, and voila! There you have it. So, through the magic of editing, we're finally on our last little strip. Kara's just putting on the negative at the moment, and then we've got the positive that goes on the inside. So I've got the whole lot in parallel, and we've tested each strip as we've gone through, and it appears to be going quite well. So here's the completed project so far. Let's try it out. Voila! Lots of lights. So the main thing we have to finish now is our socket, which will then connect into our 2 leads here, and then we can hook up our power supply, and then it'll be a freestanding unit. all we have to do now is solder it from the inside, and our job's done.
I bent the wires through, and now I'm soldering them to the doodad.
That's the technical term.
I don't understand it. I think that's it. There we go. So it's all in. And now if we plug it in, probably blow everything up.
Oh, cute. Oh, you worked really hard. Beautiful.
If you turn it around, you've got it stuck.
Thank you so much. Thank you.
Yelly helped
Thank
as
you,
well.
my lovelies. Thank
No
you,
worries.
Kara,
No problem.
for all your hard work. Are you proud?
Yes. I'll take a picture and send it to
Kara's proud. Do you want the light on or not?
Yeah.